Very good afternoon to all my students. Today we will discuss about the last but one chapter of your syllabus in estimating, and that is on service connection, overhead service connections to the consumers, single phase consumers and three phase consumers. So before going into this, we have to keep in mind certain things, that is the Indian electricity rules, which are of very vital importance so far as this estimation is concerned. So first of all, I would like to tell you that minimum clearance, ground clearance that as per Indian electricity rules that we must adhere to is 6.1 meter. When we go across any overhead line across the road, when we go minimum 6.1 meter, that is 19 feet around, we must adhere to this. Because the day you must have very recently found that in Berhampur there was a massive accident. 11 kV line came in contact with a bus and 11 people died on the spot. The very reason for that is this 6.1 meter was never adhered to. Once this sagging takes place, minimum clear this from sag point, lowest sag point to ground clearance should be 6.1 meter. So in that case, both the support system must be at higher the rate, higher the height means 8.1 meter. We must adhere to this. So before coming to this overhead service lines to consumers, we must first see what are these Indian electricity rules says. So this is your syllabus, you know, the 5 kilowatt once single phase power supply we have to calculate, 3 kilowatt single phase estimate we have to calculate, and next is a 3 phase 15 kilowatt. So before going into this detail, we will just take up a case, and this is how a single phase household, in a household what we get. This is the pole. From the pole, this height I told you minimum height, this is a vertical configuration, all the wires in vertical configuration, these are the Ltp insulators, and from here we have given power supply. It comes first to the energy meter. From energy meter it goes to a DPIC, double pole ironclad DPIC with fuse. Then it goes to distribution board, to various sub circuits. This is what is exactly our household single phase power supply. So this is, when we go for this, we have to adhere to, you see, this is a house. Here we have a GI pipe here, and single phase, these are the bare conductors with a bracket. This is called iron angle bracket, and these are the Ltp insulators. And this GI pipe, it's these wires, these bare conductors, they must keep a clearance of 4.5 meter. These are Indian electricity rules, remember. And this distance, you see here we have the main switch, main switch meter and main switch. This clearance should be minimum 1.5 meter. These are Indian electricity rules, IE rules. Or you can say Indian Electricity Act 2004. So these are the basic things we have to adhere to. These are kept because keeping safety in mind. So here you see, when this type of bare conductors with angles and insulators we give, when the distance of the pole to the house is beyond say 20 meters. So in that case that the sag will be high. If you go for a single a twin core cable, then in that case the sag will be high. So we have to go for a bare conductor which has to be with high tensile strength. It has to be strained, 8 gauge GI wire we use, because when distance is high, the sag will be more. So 3 things we have to keep in mind while deciding while giving power supply to a household. First is, number 1 is the distance from the pole, the house distance from the pole. This is first thing we have to keep. Number two is we have to see the voltage drop that can take place when full load current is taken by this household. The voltage drop from the pole to this place, to this place, it should not be more than say 2 volt. This is Indian electricity rule. So the conductor size that we decide, we should keep in mind 2 things. One is the voltage drop, another is the temperature withstand capability. So a particular conductor, it can carry a particular amount of current. So these 2 things we have to adhere to. Here you see one case I am going to take up here. In this case, we have a particular household. Here in this case, what we have done is, this is in this case particularly, we have to, this is a 20 meter distance from the pole. So 20, 40 meters, 2 GI wires, and this one is 10 meters. This total GI pipe. See, these are called saddles. We have to, and this is the earth wire. These earth wires are connected through these clamps. So because of when you are pulling, these 2 conductors are pulling, so there should be a reverse force here. So this is called stay. This is the stay bow, this is the stay rod, and this is the egg insulator, and this is the stay wire. So this stay is in the reverse direction. It should counterbalance, both the forces should counterbalance. Then only this will remain erect. Otherwise this will bend. This pole will bend. This is a GI pole. So you find that this pole is downwards because rainwater cannot enter here. It should be downward. Otherwise rainwater will also insert into it. So this cable, we have to first decide, suppose 5 kilowatt. Suppose it is a 5 kilowatt. Total load of the house is 5 kilowatt. In that case, it comes to, we can calculate, it comes to around 21.5 kilowatt, means we must say a diversity factor of 60%. What is diversity factor? Diversity factor is, if you calculate the total points, fan and light points of a household, if it comes to 5 kilowatt, then we assume that at any point of time only 60% of this fan and lights are on. So total load at any point of time, we assume 5 kilowatt into 60%, it comes to 33 kilowatt. So we have to calculate the conductor size as per 3 kilowatt. If you calculate as per 3 kilowatt, it comes to around, it comes to around 13 ampere. It comes to around 13 ampere. You see, diversity factor 60%, it comes to 13 ampere. So 13 ampere, again this 13 ampere diversity factor, for future expansion, we keep another 50% or 100% extra. Suppose somebody will come someday and he will come add another AC. So another 10 ampere will increase. So we always think of future, and with 13 ampere we add another 50%. So it comes to say 20 ampere. It comes to say 20 ampere. But when calculating the wire, the service cable, what we do, we have gone for a 10 mm square cable. Why? 10 mm square cable can take 34 ampere. We are giving 34 ampere. The reason of giving 34 ampere instead of this 20 ampere is the voltage drop. You find that if you will go to the cable sizes, you will find that in cable sizes that we have, actually here we have a cable sizes. Yes, in cable sizes 10 mm square cable, you can find that it will take 34 ampere here. It is 10 mm square cable, it will take 34 ampere, and voltage drop is 4.2. You see here, approximate length of run for 1 volt is 4.2. That means 4.2 meter, 1 volt drop. I told you I rule says from pole to the box maximum 2 volt. Now for 34 ampere current flows means 34 ampere current. So we find that 4.2 volt meter, 4.2 meter for 1 volt drop. 1 volt drop. So you see in this case, but actually our current is 13 ampere. Actually our current is 13 ampere. So 34 by 13, say roughly 3. So you multiply it with 3. So it comes to 12 meter. So up to 12 meter, if 13 ampere current flows, 12 meter you can go for 1 volt drop. So here already 20 meters. So 20 meters means it is up, we can go up to 24 meter for 2-volt drop. So since it is 20 meter, we can very well use it. We have no problem, and we have to always keep in mind, remember, frequently in the household the bulb glooms dim because of this particular reason. When we draw the service line, when we calculate to 13 ampere, we give 13 ampere service line. In that case, 13 ampere it can stand, but voltage drop will be there. As per Indian electricity rules, what we can say, we can always, the total voltage drop up to the service point from the pole, if this is the pole, from pole to the bulb, total should be, this is up to the junction box, this is the DPIC, up to DPIC it should be, you can maximum 2 volt, and here another 3.6 volt. This is total is 5.6 volt drop we can go for, not beyond that. In that, because in that case the bulb will not get the sufficient voltage to glow. So that is the main problem. Often we find this thing. And another, from pole to the transformer, from transformer secondary to the pole, we keep another 5 volt margin. So total 5% LT voltage drop, total comes to 10 volt around we allow from transformer to the switching points. So in this case, let us go back to our original case. Yes, in this case, what we have to do, we have to estimate. First these bare conductors, 20 meters GI wire. I told you 8 gauge GI wire we take for 34 amperes. This 3 wires will take 21 meter, 21 meter, 21 meter from the pole. So from the pole we have total 63 meter, 63 meters, 8 gauge wire, GI wire we take for connection. And this is the angle bracket with the shackles. These are the shackles. I am having one shackle with me, you can see. This is the shackle, and these are the U clamps or D clamps we say. The clamps, just like my fingers, are connected, and these are the shackles. This shackle insulator, and these are the conductor from the poles. So at times also we use these pin insulators. They are also used at times. So these are Ltp insulators. So now these wires, then this is the bracket. This is called angle bracket. Angle brackets are normally 50 mm cross 50 mm, and the thickness is 6 mm. 50 mm is this one 50 mm, and this one is 50 mm. I mean both this is the 90 degree angle. This is 50, this is 50, and the total length is, we take around 0.75 meter. 0.75 meter. So this, and here, so, and these are the clamps. One clamp is used from the pole for the earth wire. So this is also this earth wire also goes along with this along with this GI pole to the meter. So these are the saddles. These are saddles. To fix these saddles, what we need is, we need to make big holes there, and inside the hole we give the wooden peg, and on the wooden peg, on the holes here, we fix the knots. And the knot, the detail size knot is 150 mm length and 15 mm dia. These knots we fix there. So you see, 8 gauge wire we have taken, and the GI pipe, the total GI pipe we have calculated up to 8 meters it comes to. So, and 10 mm square cable, 7 meters we have taken, and this is earth wire. So this is 6 meters earth wire. Then comes to the pipe clamps. The clamps, I told you, these are the clamps. 2 clamps we have used. So pipe clamps, 2 numbers, and GI pipe saddles 50 mm. These saddles, actually the distance is 0.5 meter, you can say 0.5 meter we use. So next is the hook bolts or foundation for these 8 knots with foundations to hold the conduit saddle with wall. So this 15 mm dia, 150 mm long. This I told you. the LT shackles with U clamp. The shackles I told you, 2 for the GI pole and 2 for the main service pole, main service LT line. From LT line there also we need a bracket. There we also need a 2 shackles. So 2 shackle insulator, here 2, total 4 shackle insulators. Then angle service, these brackets I told you 2 numbers, one is for the pole, one is for GI with GI pipe. So at the household side. So this, then comes the ironclad. This is IC meter board. So meter board, these are the, you see, single phase meters. These are the single phase meters we place. There is one is incoming, another is outgoing. So first it comes to the meter. From meter it goes to the DPIC main switch. Nowadays we do not use this DPIC. They are old now. DPIC with KitKat fuse. They are old. Now what we use is we use MCB. This MCB, what we use now, double pole MCB. There we have to with RCCB facility. Nowadays this RCCB facility with MCB is used because in case of fire, this RCCB will trip. RCCB means residual current. So MCB, whenever we use MCB, we use a fuse also, because MCB operates for over current, but fuse operates for fault, short circuit. The moment there will be a phase neutral short circuit, then fuse will go first. MCB will take time. If you do not have a fuse, only MCB, then entire wire cable will burn, because the MCB will take time, I tell you. But if there is an overload, 5 ampere current fuse you have given, 5 ampere fuse you have given means it will actually burn out when we around 8 ampere current flows. Actually at that current it will burn. At 6 ampere it will not burn. It will not burn. But MCB will operate. The moment 5 ampere above we go, for overload this MCB operates, and for short circuit fault fuse operates. So always MCB with fuse. And nowadays this MCB has not overload only. In addition to overload, there is RCCB, means in case there is a earth fault, in somebody, a small child goes and touches a phase wire, immediately gets a shock. The moment he gets a shock, immediately supply will go off because of this RCCB. There will no human being will get any shock in any household if you have a MCCB with RCCB. So that is how these are bit costly. That is why people normally don't purchase it. But it has a tremendous safety measures within it. So another thing. So this is one thing which we find. So you see, we have come to this end. So this is another is ironclad. This IC meter board, 25 centimeter, 30 centimeter. Whenever you remember, please, that you see these meter boards. Whenever this GI pipe, when it comes to your household, here it enters a meter board. You find that here we need a lock knot. These GI pipes, we need a lock knot here. Lock knot, a hexagonal lock knot we have to give, and this lock knot, and here the conductors come out. So these lock knots, here we have mentioned here a lock knot. So another is conduit bushings also we give, wooden bushings for GI pipe 2 numbers. Stay wire, this stay wire I told you, this stay wire is opposite to the angle, the bracket. It will be one force will be in this direction, another force and another component will be in this direction. So it will be in balance condition. So this is stay wire. For stay wire, what we do here, we need a clamp, and here we need another egg insulator or stay insulator, and after that we have a bow here. This bow, and there is a knock, there is a stay rod, and this one is what we do with RCC, with PCC concrete. We just put a plate here, and that is why we have cement. We need cements, we need sand 6 bags and concrete 4 bags. These things only for fixing of this one, this particular stay rod, we have to fix it. That is why we give these things. And these aluminum clips, small clips, we give it to hold here. What we do here, you find the GI wire, earth wire goes. So these earth wire also, they have to be connected. So these are the aluminum clips also we give. So that is one packet will do. So aluminum clips, one box. So with this we have come to the conclusion how to estimate the overhead service line connection to a particular household, a single phase household. And in the next session we will discuss about giving 3-phase power supply connection to different consumers. Consumers of higher the power demand, we give their above 10 kilowatt, 12 kilowatt, we give 3-phase power supply. So we will discuss in the next class. Thank you.
झीटीए तो माटी आम सामाजिक और पारिवारिक जीवनर मूल कथाटी से माने आगकू गले आगकू जीव संसार आम झील मैंने आ पुओंकठू पछरे नाहांती एबे तो बदली गलानी समय बदली गलानी जुग से झील माननकू आहुरी आगकू नहीं आत्मनिर्भरशील और स्वावलंबी करने ओडिशा सरकार सुदक्षा योजन सरकारी आईटीआई माध्यम संपूर्ण मागणार जोगई देउछंती सबु प्रकार उत्कृष्ट मानर वैषयिक ज्ञान कौशलर तालीम एबे आम झील रहिबे सबुठू आगरे सबुठू उपरे
मु सफल मु कुशली मु सुदक्षा